Dear student, today we are going to learn about the basic introduction of operational amplifier. Student, after this lecture, you will be able to understand the basic concept of operational amplifier. The contents included in this lecture are basic introduction of operational amplifier, classification of op-amp, symbol of operational amplifier, block diagram of operational amplifier, and their applications. So, student, do you know that the first real-time computer was the analog computer? That computer was used pre-programmed equations and data. The heart of this that computer was an operational amplifier because it could be configured to perform many mathematical operations such as addition, subtraction, multiplication, division, integration, differentiation, etc. That amplifier was very large because it was built with vacuum tubes and it required a very high voltage power supply. Many early operational amplifiers were designed for analog computers, and it was soon found out that operational amplifier had other uses. So, that right now the operational amplifiers are available in integrated chip form. So therefore we can say that operational amplifier are all around of us. Like computers power supply uses operational amplifier for regulation, our cell phone uses operational amplifier for filtering and amplifying audio signals, camera signals, broadcast signals, etc. Thus, we can say that the operational amplifier is the universal analog IC because it performs all analog tasks. So this is the first, this is the introduction of operational amplifier. Here, the term of operational amplifier, that is commonly called as op-amp, was coined in the 1940s to refer to a special kind of amplifier that, by proper selection of external components such as resistor, capacitors, etc., the operational amplifier can perform a variety of mathematical operations such as addition, subtraction, multiplication, division, integration, differentiation, etc. Early operational amplifiers were made from vacuum tubes that consuming lots of space and energy. Later, operational amplifiers were made smaller by implementing them with discrete transistors. Nowadays, operational amplifiers are monolithic IC form. IC is the integrated circuit, which are highly efficient and cost effective. So the operational amplifier is a circuit which perform all the type of mathematical operations such as addition, subtraction, division, multiplication, etc., as well as amplification of some DC and AC signal. So here two terms are used here: operational amplifier. So operational means that it stands for various mathematical operations such as addition, subtraction, multiplication, etc. And amplifier means this is the circuit which boosts the signal. Since this circuit performs both mathematical operations and amplification, therefore it called operational amplifier. So the operational amplifier are widely used in electronic systems such as medical electronics, signal processing applications, audio and radio communication, instrumentation, etc. So here are the operational amplifier classifications are in two form, that is general purpose operational amplifier, and the second one is special purpose operational amplifier. So here the general purpose means it is used for a variety of applications such as integration, differentiation, summing amplifier, and others. For example, 741 IC or 351 IC. So basically general purpose means we can use this general purpose IC for various type of applications, and special purpose means that is used for some specific purpose. So it is used only for the specific applications. Example, LM380 IC. This IC is used only for audio power applications. This is the symbol of operational amplifier. This is the basic symbol of operational amplifier. So as you can see here, there are two terms: inverting input and non-inverting input. Inverting input means it is indicated by negative sign, and non-inverting, this is indicated by positive sign. So here the inverting input means an AC signal or DC signal. So here because in case of operational amplifier we can apply both AC or DC signal. So an AC signal or DC signal applied to this input produces an 180-degree out of phase or opposite polarity signal at the output. So this inverting input produces the output in form of out of 180-degree out of phase. So if we apply the input in form of sine wave, then the output will be in form of cosine form. And in case of non-inverting input, here if we will apply the input signal, then the output will be in same phase. So here if we will apply the sine wave, then the output will be in same phase, so the output will be in sine form also. So here this is the inverting input and non-inverting input. The equivalent circuit of operational amplifier. So uh, this is the basic circuit of operational equivalent circuit of operational amplifier. This circuit basically consists of Thevenin theorem, and here for analyzing the basic principle of operational amplifier and in observing the effect of feedback arrangement, its equivalent circuit is very useful. So uh, in that figure, AVID is an equivalent Thevenin voltage source and R0 is the equivalent resistance. So as you can see here, this is the uh, VID, this is the input differential voltage, this is the voltage between difference of two voltages V1 minus V2. So here the VID will be equal to V1 minus V2. So here the output voltage is V0 is equal to A into VID, and that is equal to A into V1 minus V2, because this VID is the difference of two input voltages V1 minus V2, and here A is the voltage gain. So here this A is the large signal voltage gain, VID is the difference input voltage, and V1 is the voltage at non-inverting input terminal with respect to ground, and V2 is the voltage at inverting terminal with respect to ground. So this equation includes that the output voltage V0 is directly proportional to the algebraic difference of the two input voltages. Hence, operational amplifier amplifies the difference between two input voltages. It does not amplify the input voltages themselves, since the polarity of the output voltage depends on the polarity of the difference voltage. So this is the basic equivalent circuit of operational amplifier, and here this is the block diagram of operational amplifier. So as you can see here, this is the basic block diagram of operational amplifier, and in this block diagram it is consists basically of four blocks. The first one is input stage, second one is intermediate stage, and third one is level shifting stage, and last one is output stage. So basically this input stage consists of dual input balanced output differential amplifier, and the intermediate stage is the dual input unbalanced output differential amplifier. Level shifting stage means it consists of emitter follower using constant current source, and the output stage is the push-pull amplifier, or we can say that push-pull complementary symmetry amplifier. So here these are the two input signals in form of inverting input or non-inverting input, and this is your output. So the first term in this block diagram, here an operational amplifier is a direct couple high gain amplifier, usually consisting of one or more differential amplifier, and usually followed by a level translator and an output stage. The output stage is generally a push-pull or push-pull complementary symmetry pair. An operational amplifier is available as a single IC package. So here the first one term is represented as input stage. So the input stage is the dual input balanced output differential amplifier. This stage generally provides most of the voltage gain of the amplifier and also establishes the input resistance of the op-amp. And the second one stage is the intermediate stage. This stage is usually another differential amplifier which is driven by the output of the first stage. In most amplifiers, the intermediate stage is the dual input balanced output. Because direct coupling is used, the DC voltage at the output of the intermediate stage is well above ground potential. And the third one stage is the level shifting stage. It generally this level shifting circuit is used after the intermediate stage to shift the DC level at the output of the intermediate stage downward to 0 volt with respect to ground. And that last one term is the output stage. The output stage increases the output voltage swing and raises the current supplying capability of the op-amp. A well-designed output stage also provides low output resistance. So here these are the applications of operational amplifier. The op-amp applications are commonly used for both linear and non-linear applications. So here these are the linear application of operational amplifier includes amplifiers, summers, integrators, differentiators, filters like high pass filter, low pass filter, band pass filter, band reject filter, all pass filter, etc. Non-linear applications are comparators, A by D converters, etc. Thank you.